You just connect the dots. It's a little bit easier when you don't have to do it when you have an overhead glaring at you. So there you go. So this is the final curve. You write your function, and there you go. One last example. I recommend that you do try it on your own if you're up to the challenge, which I believe you are. Okay, but you're factoring out a k here. Now the k value is -1, so be careful because that is a k value. Sometimes that's confusing. So before you sketch, you gotta think about factoring that out. Okay, another option is that you just watch my analysis of the function, then pause the video and try sketching it once we've been analyzed. So you factor out your -1, so instead of minus x minus 45, it's minus bracket x plus 45. All right. My axis is now 3. My amplitude is 0.5. So that means my max is 3.5, so 0.5 up from 3. And my min is 2.5, so 0.5 down from 3. My period is actually still 360. Okay? So really, the negative just means that I'm reflecting everything. It's a horizontal reflection. So we're going to be going from 0 to -360. Okay? And then I'm going to the left, 45 degrees. Okay? Yeah. So, we can draw this now. Okay, it's going to be on the left side of the y-axis to show that horizontal reflection. Okay? So my axis is at 3. 1, 2, 3. Y equals 3. Okay. And this is a sine function. Okay. So I want it in 360. So I'm going to do, this is 90, 180, 270, 360. Negative. So when you think about where you're quote-unquote starting, you still start here, it's just that you're going this way, so start, end, middle, instead of going this way. Okay, that's what reflecting means. So my period is 360, so I start on the axis, I end on the axis, and halfway between I'm on my axis yet again. Okay, so between my first two axis points, because think, that would be here and here, so reflected it's here and here. I'm at a maximum of 3.5, and here I'm at a minimum of 2.5. So it's just kind of a little shallow curve there. Okay, now I'm moving everything left 45 degrees. Each tick here is worth 90, so that's just half a grid square. So there you have it. That is the curve right there. Okay, so you can continue it in this direction, or you can continue it in this direction, right? So another half over, I'd be going down. Another half over, another full square over, I'd be down. Another full square over, I'd be at an axis. Another full square, I'd be up, axis, down again. So I can continue doing cycles as much as I want. Okay, and there you have it. So those were a lot of examples of sketching sinusoidal curves. 5 to be exact. So I hope that was good enough, and now you have this to refer to at any time. Okay, I'm just checking. All right, so the last 2 examples I have are actually when you're given a curve and you have to come up with an equation. So this actually says identify 2 possible equations. So there's many ways to identify two different equations for the same graph because they're periodic. So either you can just do different phase shifts, or you can actually do one of the equations as a sine and one of the equations as a cos. But in order to do this, we have to identify what the axis is and the amplitude and all of our key things. So really the easiest thing to do is to identify the max and the min. Okay, so our max is 3, and our minimum is -5. Okay, so the axis, remember, is always just the average of those two. So 3 minus 5 divided by 2 is -1. So that means that the axis is -1. So our C value is -1, no matter what, for sure. Okay, so you can kind of draw that if you want. So once we have the axis, you can then come up with the amplitude. So the amplitude is pretty clear, is equal to 4, right? Because the distance between -1 and 3 is 4, or the different distance between -1 and -5 is 4. Okay? You can also just do the max minus the axis to figure that out. So 3 minus -1 is 4. Okay? So now that means our A value is 4. So now we already have 2 of the 4 parameters that we need. So next we need to find out the K value, which is determined by our period. So the period, it starts here and it ends here, and that's 180 degrees, okay? If you can't tell, the max there, sorry, this axis point is at 90, this is at 180. So the period is 180 degrees. Okay, so remember the period, 180 degrees, equals 360 divided by K. So to solve for K, you just can switch these guys places. Okay, so multiply this up and then divide the 360 down. So K is just 360 divided by 180, so 2. So our K value is equal to 2. Now, there's no phase shift if you use sine, okay, because it starts on an axis. So if we're using sine, then the value, or our equation would be 4, that's our A value, sine 2x minus 1, okay? We have the A value, the K value, and the C value. Now, if we want to use cos, we just need to incorporate a phase shift. So we need to shift it to where the maximum is, okay? So that would mean that sine has been, so to use cos, your D value has to be 90 degrees, okay? To show that it's been shifted to the right 90 degrees, okay? Because originally, cos would have been here, okay? Normally your cos would have been at 0 at a maximum, but now it's here. Okay, often students think, well, my maximum is here, so I need to get it back, and they think that they have to go left 90. That's not right. You have to think of where was cos originally, and what happened to that original cos to get it to where it is now. So what change happened to the original cos to get it to its new position? So that means it was moved right 90 degrees, okay? So our D value is 90 degrees. So that equation would be y equals 4 cos 2 bracket x minus 90 bracket bracket minus 1. So think about it. Why do you need the double brackets here? Well, remember, to see the phase shift, K is factored out. Okay, so to show that as being 90, you have to keep it separate from K. Now, I'd like you to think about what would change if we decided to do a negative cos. So negative 4 cos something 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 minus 1. What would change? Well, that just means that we would shift the whole thing over to where it's at its minimum. Okay, that's how that would change. So it would be x minus 135. okay, if we use -4. So there's actually infinite ways that we can represent one curve because of the sinusoidal nature. Another option is that we could add 360 degrees to this, because that just moves it over one period, so it's the exact same curve. All right, so there's lots of different ways to come up with an equation, but the things that will never change are the amplitude, the axis, and the period. The phase shift could be different, whether it's negative or positive, cos or sine could be different, but your A, your K, and your C, there's only one possibility for those three different parameters. Okay, here we go, last one. So this is a bit more complicated because it doesn't show the entire cycle. But we do see half of a cycle because we see a minimum of -1 to a maximum of 5. So we can come up with our axis, okay, -1 plus 5 divided by 2. So that's 2. So that means our C value is equal to 2. Okay, and we can draw the axis to help our visualization of what's going on. Okay? Then we can come up with the amplitude. Okay, between 2 and 5, it's 3. Okay, so our A value is equal to 3. The period. Okay, this is a bit more complicated because you can't necessarily see what these values are. I know it's not completely clear. So this coordinate here is 45, 2. Okay, this coordinate here is 225, 2. And this coordinate here is 405, 2. Okay, so actually we do have an entire cycle that goes from 45 to 405. So the period is just the length between 45 to 405. So 405 minus 45 is 360. So because our period is 360, that means there is no K value other than 1 because we haven't stretched or compressed this at all. So we can just do y equals, okay, now let's say we want this to be the quote-unquote start of the function, this point here. Notice that's at the axis, we go down, axis, up, and back. So starting at the axis is always sine, but when you start at the axis and go down, that's negative sine. Okay, oh, and I forgot the A value, so -3 sine, okay. Then we need a phase shift, so if this was normal negative sine, it's been moved over 45, so we do minus 45, and then plus 2. Okay, that's one option. Okay, we could also do, this point here is 135, comma -1. So we could also do a -3 cos function, a negative because we're starting at the minimum. And that's been moved over 135 degrees, plus 2. Okay, now let's say I wanted to do a positive sine function. So a positive sine function starts at an axis and then goes up. So that means I would quote unquote start here. So it would be 3 sine, not negative anymore, x minus 225 to get over there, and then plus 2. All right, so you can try giving an example of what would the positive cos be. Okay, that would just be moving it so that it quote unquote starts at a maximum. Okay? Phew, it's a lot of stuff. I know this was a long video. So I hope that you were able to get through this transformation stuff. Really it all goes back to understanding originally how transformations work from Unit 1, and also understanding how we came up with the sine and cosine curve in the first place. So thanks for watching. I hope you learned lots.